This is SpaceTime Series 25, Episode 42. Coming up on SpaceTime, Artemis I undergoes a full launch dress rehearsal, NASA to purchase more lunar landers, and Blue Origin launches its fourth space tourism flight. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
2 weeks after rolling out onto Space Launch Complex 39B from the historic Vehicle Assembly Building at the Kennedy Space Center in Florida, NASA's massive new moon rocket, the SLS or Space Launch System, has undergone its long-awaited 3-day wet dress rehearsal. The complicated series of pre-flight checks and procedures includes filling the 98-meter-tall SLS rocket and Orion spacecraft with the different fuels and liquid oxidizers used during the launch and ascent sequence. Mission managers and ground crew practiced a range of different countdown scenarios in preparations for the launch. The dress rehearsals always start with communication systems on the Orion spacecraft being powered up and tested. Ground crews then carry out their launch pad reconfiguration process, which includes things like positioning the launch pad's flame detectors and removing handrails. Technicians then load the tanks of the rocket's core and upper stages with the cryogenics used for flight, including the propellant liquid hydrogen chilled to minus 268 degrees Celsius and liquid oxygen chilled to minus 169 degrees Celsius. Mission managers then undertake a full dress rehearsal countdown, during which cryogenic recycling is maintained to keep the tanks full. The teams initially count down to T-minus 1 minute and 30 seconds and then pause to demonstrate the system's ability to go into a hold for up to 3 minutes. They'll then resume counting down, reaching 33 seconds before launch, at which time they'll pause yet again, and then rewind to 10 minutes before launch. A second terminal countdown then begins, this one getting all the way to T-minus 10 seconds before launch, before holding. By this time, some of the umbilicals connecting the launch vehicle with the pad and tower will have already begun their auto-release programs. These complicated scenarios are designed to allow mission managers to test a range of scenarios in which a launch could be cancelled or scrubbed due to technical issues, weather conditions, or range safety concerns. But unlike past occasions, we won't always be told what's going on when. Not all the details of the tests will be released. That's because of new international traffic in arms regulations, which prohibit sharing or exporting of sensitive information such as cryogenic timing details, which could assist an enemy power in development of their own ballistic missile systems. It means no information on data relating to specific timings, flow rates and other characteristics associated with the launch vehicle and its systems or the specific operations they're going through will be released. Once the wet dress rehearsal is complete and the rocket's fuel tanks have been drained, the SLS and Orion will roll back to the Vehicle Assembly Building for additional testing prior to launch. NASA mission managers will then review the data and address and resolve any unusual or unexpected outstanding issues. Once all that's done, they'll set a final launch date for the Artemis I flight. And once all of that's complete, the whole vehicle, in its final configuration for launch, will then be rolled back out onto the pad for launch operations. This report from NASA TV.
The first integrated flight test of the Orion spacecraft and the Space Launch System rocket launching from the Kennedy Space Center is about to unfold. This is the first of many missions to come that will use the Deep Space Exploration System to prepare our team, our ship, and our astronauts for human operations in deep space. Rollout from the Vehicle Assembly Building signals that launch is near. Sitting atop the mobile launcher, the crawler transporter moves along the crawlerway towards historic Launch Pad 39B at the Kennedy Space Center at a top speed of 1 mile an hour. After traveling over 4 miles, the rocket and the spacecraft climb up a ramp and are positioned over a flame trench. Once in position, the mobile launcher is lowered onto support post and the crawler is rolled away to a safe distance. Final checks are performed at the pad, including crew cabin closeout via the access arm sitting over 300 feet above the surface of the launch pad. The launch date is set, and the teams are prepared for the mission that is about to occur. It's sunrise on launch day. Engineers in the Launch Control Center have already powered up the spacecraft and the rocket and loaded the core stage and upper stage with cryogenic fuel. As launch window open approaches, final checks are performed, and when all systems are go, terminal countdown is initiated. The big physics of launch are about to be put on full demonstration. Umbilical plates weighing hundreds of pounds await their cue to retract to clear the path of the rocket at liftoff, some mounted on arms the size of tractor trailers. The mighty core stage engines are prepared for engine start as they are thermally conditioned for an onrush of cryogenic fuel in the heat of ignition. At T-minus 15 seconds, sound suppression is activated, cascading water into the flame trench to dampen the acoustic shock. And as the core stage engines achieve full throttle, shock diamonds appear. At booster ignition, the flame trench is flooded with fire. At first motion, all umbilical arms are retracted, and the rocket clears the tower in just seconds. At liftoff, the vehicle produces 8.8 million pounds of thrust and lofts the vehicle weighing nearly 6 million pounds and standing 32 stories tall to orbit. Propelled by a pair of 5-segment boosters and 4 liquid engines, the rocket achieves maximum dynamic pressure only 90 seconds into the mission, the period of greatest atmospheric force on the structure of the rocket. Thousands will gather in Florida to watch our ship get smaller and smaller and leave the Space Coast behind. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely jettisoned. The rocket will continue on, guiding itself to orbit with magnificent precision. Just 3 minutes into the mission, the service module fairings are jettisoned to lighten the vehicle and expose Orion's solar arrays. Just 40 seconds later, the launch abort system is also jettisoned. It is no longer needed. Orion could safely abort at any time. Once at the desired velocity target, the core stage engines are shut down and the core stage separates. The interim cryo-propulsion stage with Orion will continue to orbit the Earth. Along the way, they will pass through the altitude of the International Space Station at 250 statute miles. During this first orbit, the solar arrays are deployed so that Orion no longer needs battery power. It can now produce its own power. Following solar array deployment, the arrays are positioned into a load-bearing configuration to prepare for the perigee raise maneuver. The raise maneuver will ensure an Earth orbit and use the thrust provided by the interim cryo-propulsion stage. Once the perigee raise maneuver is complete, Orion systems are checked prior to committing to the translunar injection, or TLI maneuver. The TLI maneuver must be successfully completed to depart Earth orbit. The TLI burn is approximately 20 minutes in duration and increases the spacecraft's velocity over 9,000 feet per second, a speed change faster than a high-powered rifle bullet travels. Following TLI, Orion is committed to a lunar trajectory, just 1.5 hours after launch. Once complete, the spacecraft adapter will remain with the interim cryo-propulsion stage, and they will separate from Orion. As Orion departs low Earth orbit, it will fly through the orbital debris field encircling the Earth, past the global positioning navigation satellites, past the communication satellites in geostationary orbit, and through the Van Allen radiation belts, on into the deep space radiation environment. Orion is now entering an outbound coast phase. The spacecraft is uniquely designed to navigate, communicate, and operate in this deep space environment. The outbound coast to the Moon will take approximately 4 days. As Orion approaches the Moon, the service module will be used to perform a critical lunar gravity assist maneuver, allowing the ship to enter a distant retrograde orbit about the Moon. The Moon will get larger and larger in the window, and at closest approach, Orion will be just 62 miles from the surface of the Moon. As the spacecraft flies around the far side of the Moon, we will lose all communication back on Earth, and for a period of time, Orion will be on its own. Mission Control will await acquisition of signal, and as we lock on, a new generation will see their first Earthrise. The spacecraft is now in the distant retrograde orbit, where its systems will be tested in the deep space environment for over a week. Along the way, our ship will travel farther from Earth than any human-capable spacecraft has ever gone. At the farthest point, Orion will be some 1,000 times farther from Earth than the International Space Station, at over 270,000 miles away. Teams in Mission Control Houston and at Naval Base San Diego will prepare for Orion's return home, and the recovery ship will set sail for the recovery zone in the Pacific Ocean. Orion will exit the distant retrograde orbit with another lunar gravity assist in-service module engine firing. Along the way, the trajectory will be adjusted to target the Earth's thin atmosphere at over 250,000 miles away and ensure precision landing in the Pacific Ocean following a direct entry. During the coast home, Orion will maintain the desired tail-to-sun attitude to optimize spacecraft cooling and maximize power production in the deep space environment. Another 4 days return coast home to Earth. As our home planet fills the windows of Orion, an important contribution from our European partners called the service module has done its job. The service module is jettisoned and separates. Following separation, the world's largest heat shield will be oriented into the direction of travel to prepare for entry interface at an altitude of 400,000 feet. At entry interface, Orion will hit the Earth's atmosphere traveling at a speed of 24,500 miles an hour and decelerate at up to 9 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the surface of the Sun, approaching 5,000 degrees Fahrenheit. Orion will continue to decelerate, pass through the sound barrier, and announce its arrival to the waiting recovery team with a sonic boom. Following peak heating, a protective thermal cover that sits over the parachutes will be jettisoned. This begins a series of parachute deployments. The drogue chute deployment series is designed to stabilize and slow the spacecraft, and in a period of less than 20 minutes, Orion will slow from a speed of Mach 32 to 0 at splashdown. The 3 main parachutes will deploy and slowly unfurl and suspend the 22,000-pound capsule and allow it to gently descend to the surface of the ocean. After 25 and a half days, and a total distance traveled exceeding 1.3 million miles, a precision landing within eyesight of the recovery ship. Following splashdown, Orion will remain powered for a period of time as Navy divers approach in small boats from the waiting recovery ship. After a brief inspection for hazards, the divers will hook up tending lines and a tow line. The capsule will be then towed into the well deck of the recovery ship, and once the capsule clears the stern gate, the gate will be closed, the well deck will be drained, and we will bring our ship home.
This is SpaceTime. Still to come, NASA to purchase more lunar landers for its Artemis program, and Blue Origin launches its 4th space tourism flight. All that and more still to come on SpaceTime. NASA has announced plans for more options for manned lunar lander spacecraft to transfer people and supplies between the Lunar Gateway space station and the surface of the Moon. Back in April 2021, NASA selected SpaceX to develop a version of its reusable Starship Colonial Transport spacecraft to provide shuttle services between lunar near rectilinear halo orbit and the lunar surface. SpaceX's Starship spacecraft and its Super Heavy launch vehicle are designed to operate as a fully reusable human-rated launch system capable of carrying more than 100 tons into low Earth orbit, as well as on longer journeys to the Moon, Mars and beyond. The lunar lander variant of Starship, known as the Human Landing System or HLS, will transport astronauts from lunar rectilinear halo orbit down to the lunar surface and back again. Once it's launched from Earth, the HLS will never again enter an atmosphere, so it doesn't need a heat shield or flight control surfaces. In contrast to other HLS designs that propose multiple stages, the entire Starship spacecraft will land on the Moon and then launch again back into lunar rectilinear orbit. Like other Starship variants, Starship HLS will have 6 Raptor engines mounted in the tail. They're needed to act as a second stage booster during launch from Earth. And because they're reusable, they'll also be used for primary propulsion during other phases of flight. But unlike other Starship variants, for attitude control within 100 meters of the lunar surface, the HLS variant will utilize 24 high-thrust reaction control system thrusters located mid-body to avoid plume impingement problems with the lunar regolith. These RCS thrusters will burn gaseous oxygen and methane instead of the liquid oxygen and methane used by the Starship's main Raptor engines. The HLS is designed to be capable of a 100-day loiter capability in lunar orbit. It'll also be capable of transporting payloads of more than 100 tons between lunar orbit and the lunar surface and then back again. That far exceeds NASA's requirement of less than 2 tons descending to the lunar surface and a single ton ascending back to lunar near rectilinear halo orbit. But getting the Starship HLS to the moon won't be simple. The mission will involve a Super Heavy booster launching the Starship HLS into Earth orbit, where it will then be refueled by a Starship variant configured as an orbital propellant depot. SpaceX says between 4 and 14 Starship tanker variants carrying propellants will be needed to be launched in order to fill the orbital fuel supply depot. Once refueled, the Starship HLS will be able to boost itself into a lunar near rectilinear halo orbit. NASA says SpaceX will carry out an initial unmanned HLS test flight from lunar near rectilinear halo orbit down to the lunar surface and then back again as proof of concept. If successful, a second HLS flight will then travel to lunar near rectilinear halo orbit, where it will rendezvous with a manned Artemis I Orion spacecraft that will launch from Earth aboard a Space Launch System SLS rocket sometime around, at this stage, April 2025. By the way, in case you missed it, that's an apparent admission that the new Lunar Gateway space station won't be ready in time. 2 of the crew members will then transfer from the Orion Artemis III capsule to the HLS, where they'll descend down to the lunar surface for a stay of several days, which will include 5 or more extravehicular activities or spacewalks. The HLS will then return the crew to the Orion in lunar near rectilinear halo orbit for the return journey to Earth. Later missions will see the Lunar Gateway space station used as a transfer point and staging post in lunar near rectilinear halo orbits, where both Orion and HLS will dock and transfer crews, supplies and equipment. Back in September 2020, Musk stated on Twitter that there was really no need to bring early HLS vehicles back from the surface into orbit, as they could stay there and be used as lunar habitats. Meanwhile, NASA have now announced its intentions to purchase a second crewed Starship HLS demonstration mission to the moon, this one using a slightly altered HLS design updated to meet new sustainability requirements. The new updated Starship HLS would be used for the Artemis V mission to the lunar surface, and it would compete with other vendors for later landings. But in addition to the Starship HLS, NASA's also now announced plans to have another company provide an alternate design in order to meet redundancy and competition requirements. This is nothing new. NASA used 2 different spacecraft, Boeing and Dragon, to send crews to the International Space Station, and 2 different cargo ships, Cygnus and Dragon, to send supplies to the orbiting outpost. And that should soon be increased to 3, with Sierra Nevada's Dream Chaser joining the group later this year. As for the new lunar landers, they'll need to have the capacity both to dock with the Gateway space station, increase crew capacity, and transport more science and technology down to the surface. Under the Artemis program, NASA's not just returning to the moon after an absence of 50 years, but Artemis and Gateway will provide the jumping-off point for eventual manned missions to Mars sometime in the next decade. It's all very exciting. This is SpaceTime. Still to come, Blue Origin launches its 4th space tourism flight. And we look at our nearest neighbouring star system, Alpha Centauri, the iconic constellation Southern Cross, and the annual Lyrids meteor shower on this month's SkyWatch. Blue Origin has launched its 4th suborbital space tourism flight aboard one of the company's new Shepard rockets. The 10-minute ballistic ride from the company's West Texas launch facility to the edge of space carried 6 new space tourists to an altitude of more than 351,000 feet, well above the 328,000-foot or 100-kilometre high Kármán line, which marks the internationally recognized official start of space.
1, 0. Shepard cruise tower.
And liftoff. Mission Control has confirmed New Shepard has cleared the tower and is on its way to space with our 4th human flight crew.
Godspeed, New Shepard. Godspeed, the Roaring Twenties. Enjoy this ride.
We are gaining speed as New Shepard lifts off towards space.
10,000 feet.
That beautiful burn on that BE-3 engine lifting New Shepard towards space.
As we hit T plus 55 seconds, we will enter max Q, the point
Max
where
Q.
aerodynamic stress on the vehicle is at its maximum. We just confirmed max Q, and that BE3 engine doing some work, 8,000 horsepower equivalent of it, to produce 110,000 pounds of thrust on its way to space. The BE3 engine there and its colorless exhaust, that's what happens when you mix liquid hydrogen and liquid oxygen. That is steam powering the rocket all the way up to the top. Here in 20 seconds, the BE3 will throttle back, shut down, and will reach main engine cutoff. There it is, Miko, way to go, BE3. Thank you for powering our astronauts to space.
That was our main engine cutoff. Shortly here, we'll see separation of the crew capsule and the booster. At this point, our Capcom Kevin Sprague will momentarily cue the astronauts to unbuckle their harnesses and start floating around the capsule. Welcome to Zero Gravity, Gary Lai and crew of the Roaring 20s. Two separate craft, George Neal, Sharon and Mark Hagel, Jim Kitchen, Marty Allen, and Gary Lai. Welcome to Zero G.
First step, Blue Control. This is your 1 minute warning. 1 minute warning.
Congratulations to all 6 crew. They crossed that Kármán line. They just officially became astronauts. Absolutely outstanding. You heard that audio online from Kevin Sprague, our capsule communicator, telling our crew, I'm sure they're having an amazing time up there, but they have to start getting ready to buckle back in. Shortly here, both the crew capsule and the booster will be descending.
That's right, Jackie. So unofficial numbers, but we saw an apogee of 351,000 feet. So definitely well into the Kármán line, well into space. Congratulations, astronauts. The rocket is now reaching, this is the booster portion of New Shepard, is reaching its atmospheric pierce point. It's returning from space. Those control surfaces, those wedge fins, those actuated aft fins are now starting to have a little bit of air resistance to push against. The booster will reach its maximum re-entry velocity, which is just under Mach 4. That's 4 times the speed of sound, and it's an incredible booster shape coming back down over the West Texas desert against those Texas blue skies. This is the fun part. The wedge fins, the steering fins, the ring fin, all earning their keep at this point. Really doing some work to bring that propulsion module over the landing pad. Here shortly will the air brakes deploy that will cut the velocity of the booster in half. There it is. This is a critical step in slowing the vehicle down before the BE3 engine is reignited for the final portion of the descent. We had a sonic boom. Man, was that incredible. I love hearing that sound. And the BE3 engine relights for the final portion of the descent. Touchdown, New Shepard. Welcome back to Earth. What an incredible feat of engineering required to bring this rocket back safely, reuse it. All I can ever say, Jackie, is wow.
Wow, Eddie, truly, no matter how many times we've seen this happen, a live booster landing onto that landing pad will take your breath away.
And we see, of course, the New Shepard propulsion module beginning to dump some of the excess propellants. That's a key step for our reusable booster. We'll vent the tanks, we will inert them. That'll maintain the cleanliness throughout and allow that booster to turn around and fly.
There go the drogue parachutes they've deployed on our crew capsule to slow it down. And there go those main parachutes. Those 3 mains will slowly inflate to help slow down the return of the crew capsule. While the parachutes are, of course, essential to provide a gentle touchdown for the crew capsule, New Shepard also has that innovative retro thrust system to make our touchdown even smoother for the Roaring 20s crew flying today. From the blackness of space to the beautiful West Texas desert, our crew is getting an experience right now.
That was a quick 10 minutes. Get ready for the ground rush.
First step, Blue Control. Stand by touchdown. Stand by touchdown.
Woo! Crew capsule touchdown. Welcome back, the Roaring 20s.
That sounds like some happy crew members there.
Blue Origin's past flights have included the company's founder, Jeff Bezos, as well as Star Trek icon, William Shatner. Meanwhile, Elon Musk's SpaceX is targeting next week to fly 3 space tourists and a former astronaut aboard the Axiom 1 mission to the International Space Station using a SpaceX Dragon capsule powered by a Falcon 9 rocket from Space Launch Complex number 39A at the Kennedy Space Center in Florida. This is SpaceTime. And time now to check out the night skies of April on SkyWatch. April is the 4th month of the year in the Gregorian calendar and the 5th in the early Julian calendar. The Romans gave this month the Latin name Aprilis. Although the name's origins aren't certain, traditional entomology suggests it's from the verb aperire, to open, as in it being the season when the trees and flowers begin to open as the northern hemisphere moves into spring. April is also Prevention of Cruelty to Animals Month, and so it's a good time to consider adopting a shelter pet or donating to an animal welfare charity. High in the southern sky during April, you'll find the Southern Cross and its 2 pointer stars, Alpha and Beta Centauri. The more distant of the 2 pointer stars from the Southern Cross is Alpha Centauri, which also happens to be the nearest star system to our own. Located some 4.3 light-years away, Alpha Centauri actually consists of 3 stars. There's Alpha Centauri A and B, which orbit each other, and Proxima Centauri, which orbits the pair. And at 4.25 light-years distant, is currently the nearest star to the Earth other than the Sun. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It's slightly bigger, having about 1/10 more mass than the Sun, and has about 50% more luminosity. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are spectral type M red dwarf stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral to represent luminosity. So, our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars called brown dwarfs. These are sometimes born as spectral type M red dwarf stars, but become brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Orbiting in a binary system with Alpha Centauri A is Alpha Centauri B, a spectral type K orange dwarf star, a little smaller and cooler than the Sun, with about 0.9 times the Sun's mass and about half its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years. The distance between the two stars varies between roughly that of Pluto and the Sun and that of Saturn and the Sun. The third star in the system, Proxima Centauri, sometimes called Alpha Centauri C, is a spectral type M red dwarf star, with roughly 1/7 the diameter and about 1/8 the mass of the Sun. It takes around 550,000 Earth years to orbit Alpha Centauri A and B. The nearer of the 2 pointer stars to the Southern Cross is Beta Centauri, also a triple star system, but this one located a far more distant 390 light-years away. All 3 are massive young blue stars, far larger and more luminous than the Sun. 2 of the stars, named Beta Centauri AA and Beta Centauri AB, orbit each other, while the third star, Beta Centauri B, orbits the primary pair every 1500 Earth years. Beta Centauri AA and AB are known as a spectroscopic binary, orbiting each other every 357 Earth days. Spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our point of view here on Earth at least, by their spectroscopic signatures. Both these stars are now reaching the end of their time on the main sequence and will soon run out of the core hydrogen they use for fusion, the process which makes stars like the Sun shine. The two pointer stars, Alpha and Beta Centauri, are named after Chiron, the centaur, a mythological Greek being half man, half horse. Chiron taught many of the Greek gods and heroes, but was placed among the stars after accidentally being shot with a poison arrow by Hercules. Next to the pointer stars is the spectacular Southern Cross, or Crux, the smallest but one of the best known of the 88 constellations in the sky. The Southern Cross is considered an important constellation for navigation and is featured on the flags of several nations, including Australia, Brazil, New Zealand, Papua New Guinea and Samoa. In April, the Southern Cross lies on its side in the early evening, but becomes more and more upright as the night progresses. The bottom and brightest star in the Southern Cross is Alpha Crucis, or A Crux, which is actually a multiple star system located 321 light-years away. It consists of three stars, A1 Crucis, which is a spectroscopic binary, and A2 Crucis. A2 Crucis and the primary star in A1 Crucis are both spectral type B blue stars, with surface temperatures of 26,000 and 28,000 Kelvin respectively. The two components orbit each other every 1,500 Earth years at an average distance of around 430 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres or 8.3 light minutes. The spectroscopic binary A1 Crucis is thought to comprise two stars, with about 10 and 14 times the mass of the Sun respectively. The pair orbit each other every 76 Earth days at a distance of around 150 million kilometres, in other words, one astronomical unit. The masses of A2 Crucis and the larger component of A1 Crucis are expected to eventually explode as core collapse supernovae, ending up as neutron stars, while the smaller component of A1 Crucis could survive as a white dwarf. The left-hand and second brightest star in the Southern Cross is called Beta Crucis, and it's also a spectroscopic binary, consisting of two stars orbiting each other every 5 Earth years, at an average distance which varies between 5.4 and 12 astronomical units. Beta Crucis is located some 280 light-years away. The primary star, Beta Crucis A, is a spectral type B Beta Cephei variable blue star, which changes in brightness over a period of around 4 to 4.5 hours. It has about 16 times the Sun's mass, about 8 times its diameter, and a surface temperature of some 27,000 Kelvin. By comparison, our Sun has a surface temperature of just 6,000. The second star in the system, Beta Crucis B, has about 10 solar masses. A third companion has also been detected in the system. However, it appears to be a low-mass pre-main sequence star which hasn't yet commenced nuclear fusion. Near Beta Crucis is the spectacular young open star cluster known as the Kappa Crucis cluster, or NGC 4755, and more commonly referred to as the Jewel Box, the name given to it by famous 18th century astronomer John Herschel. Open star clusters are groups of stars which were originally all born at the same time out of the same collapsing molecular gas and dust cloud. Although somewhat still gravitationally bound to each other, stars in open clusters eventually separate, moving to other parts of the galaxy. As the name suggests, the Jewel Box is a stunning collection of more than 100 bright, colourful stars, located some 6,440 light-years away, although its exact distance is somewhat difficult to determine because of the nearby Coalsack Nebula, which obscures some of the light. The Coalsack is a dark nebula containing lots of gas and dust blocking out background stars. In Australian Aboriginal Dreamtime legend, the Coalsack forms the head of the Emu constellation, with the dark dust lanes of the Milky Way forming the emu's body and legs. The central parts of the Jewel Box are framed by bright stars making up an A-shaped asterism. These are among the brightest known blue, white and red supergiants in the Milky Way. Gamma Crucis, which is located at the top of the Southern Cross, is the third brightest star in the constellation. It's also one of the nearest red giants to our solar system, located just 88.6 light-years away. Although only 30% more massive than the Sun, its expanded outer envelope is bloated out to some 84 times the Sun's radius, and is radiating some 1,500 times more luminosity than the Sun. As a red giant, no longer on the main sequence, Gamma Crucis is nearing the end of its life. Its surface temperature is some 3,626 Kelvin, and it has a prominent reddish-orange appearance. The star on the right-hand side of the Southern Cross is Delta Crucis, a massive, hot and rapidly rotating star that's in the process of evolving into a red giant and will eventually end up as a white dwarf, the stellar corpse of Sun-like stars. Delta Crucis is located some 345 light-years away and has about 9 times the Sun's mass and 8 times its radius. It's presently radiating at around 10,000 times the luminosity of the Sun at an effective temperature of 22,570 Kelvin, causing it to glow with a blue-white hue. The smallest star in the Southern Cross is Epsilon Crucis, which is located in the space between Delta and Alpha Crucis. It's a red giant, some 228 light-years away. It has about 1.42 times the mass of the Sun and about 32 times its radius. Its surface temperature of 4,148 Kelvin means it's sometimes referred to as an orange giant. The Southern Cross is at its highest point in the southern sky this time of year and is pointing directly at the southern celestial pole. It's within the constellation Centaurus the Centaur, the half-man, half-horse of Greek mythology we mentioned earlier. The creature is holding a bow loaded with an arrow. The Centaur's front leg is marked by the 2 pointer stars Alpha and Beta Centaurus. His back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster visible with the unaided eye from dark locations. Unlike open star clusters, globular clusters are tightly packed spheres containing thousands to millions of stars, which were originally all thought to have been born at the same time from the same molecular gas and dust cloud. Omega Centauri is about 16,000 light-years away. It's one of the largest and brightest of the hundreds of globular clusters known to orbit around the Milky Way galaxy. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. The constellation Orion the Hunter is still clearly visible in the northwestern sky this time of year, with its rectangle of 4 stars surrounded by a central trio of stars which form Orion's belt. To the right or east of Orion is the constellation Gemini and its 2 brightest stars, Pollux and Castor. This time of year, the Gemini twins are almost directly due north for Southern Hemisphere skywatchers. The higher of the 2 stars, Pollux, is a red giant, some 11 times the diameter of the Sun and located just 34 light-years away. The other star, Castor, is much further away, some 51 light-years. Look to the east and you'll see the star Regulus, the brightest star in the constellation of Leo the Lion. Regulus, which means Little King, is located 77 light-years away and is about 3.5 times as massive as the Sun and about 140 times as luminous. Regulus is a binary companion star, which takes 130,000 years to orbit the primary. To the right of Regulus, and virtually due east in the sky right now, is the star Spica. Located directly below the 4 stars in the constellation Corvus the Crow, Spica is the brightest star in the constellation Virgo. Also known as Alpha Virginis, it's the 16th brightest star in the night sky, and is another spectroscopic binary, comprising 2 stars closely orbiting each other every 4 Earth days. In fact, the 2 stars in Spica are orbiting so close together that the gravitational interaction between them has caused them to become rotating ellipsoidal variables, distorting them into the shape of a rugby league or gridiron football. Light from this binary changes in brightness as the 2 stars orbit each other, exposing their elongated hemispheres to us. Spica is located some 260 light-years away and is some 2,000 times as luminous as the Sun. Spica means ear of wheat, which Virgo is holding in her hand. It's so named because it marks the start of the harvest season in the Northern Hemisphere. The primary is a blue giant variable beta Cepheid, which undergoes small rapid variations in brightness because of pulsations in the star's surface thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7.5 times its diameter. Once a spectral type B blue-white main sequence star, it's now pulsating rapidly, rotating at more than 199 kilometers per second over a 0.1738 Earth-day period. It's one of the nearest stars to the Earth, which is expected to end its life as a Type II core collapse supernova. The second star in the system is also thought to be a spectral Type B blue-white giant, about 7 solar masses and 3.6 times the Sun's diameter. Okay, going back to the Southern Cross and looking to the right or west, you'll see the star Canopus. It's the second brightest star in the night sky after Sirius. Even though Canopus is 312 light-years away, it looks incredibly bright because it's huge, 100 times the diameter of the Sun and 10,000 times as luminous. This year's second major meteor shower, the Lyrids, will peak on April the 22nd and 23rd. The Lyrids appear to radiate out from the constellation Lyra, close to the star Vega, one of the brightest stars in the sky this time of year. The source of the meteor shower are particles of dust and debris shed by the long-period comet C1861 G1 Thatcher. SkyWatchers in the Northern Hemisphere get the best view of the Lyrids. However, listeners at mid-Southern Hemisphere latitudes can also see the shower between midnight and dawn. Patient observers will be rewarded with around 18 meteors per hour before dawn from dark sky locations. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.